So the Rolle's theorem states that if you have a function at the interval a comma b, if on the closed interval a comma b is continuous and on the open interval is differentiable, and f of a is equal to f of b, which means that they have the same output or y value, then that means there exists a value c somewhere in the open interval of a to b, where the tangent line or the derivative at that point is 0. And here I drew a graph that represents a function that applies to the Rolle theorem. We have the closed interval a comma b being continuous, and we have the open interval a comma b being differentiable, and they have the same y value. And the Rolle's theorem states that for something like this, there's a value c somewhere on this interval of the graph where the derivative is 0. And let's say the point C is right here, then the tangent line would be horizontal. And you might notice that this is a special case of the mean value theorem, which is basically the same thing, but the mean value theorem says that the secant line is equal to the tangent line for some point C. And the Rolle's theorem is just the mean value theorem, just rewritten for a specific case where the tangent line is horizontal. So first, let's do an example to see how the Rolle's theorem works. Let's say we have this function f of x equals x squared minus 3x plus 2, and we have the interval 1, 2. In order to apply the Rolle's theorem, we need to meet 3 conditions like we discussed, and the first 2 are that it must be continuous over this closed interval, and that it must be differentiable over the open interval. And since this function is just a regular quadratic, there's not going to be anything like that prevents it from being that. It's going to be differentiable over the entire function and continuous over the entire function. And the one condition we must check is that if f of 1 is equal to f of 2, because 1 is our a and 2 is our b. So first, let's see what f of 1 is. So f of 1 is equals to 1 squared minus 3 times 1 plus 2, which is 1 minus 3 plus 2, and that's just equal to 0. And now let's try f of 2. This is 2 squared minus 3 times 2 plus 2, which is 4 minus 6 plus 2, which is equal to 0. And as you can see, f of 1 is equal to f of 2. They're both 0, so we can apply the Rolle's theorem now. And the Rolle's theorem says that in between this interval, there's a point C such that the derivative is 0, and there's a horizontal tangent line at that point. And if we want to find this, we would need to set the derivative equal to 0, but first we need to find the derivative, so f prime of x is equal to 2x minus 3. We can set this equal to 0 in order to find the point where the derivative is 0, or our c value. And we get x equals 3 over 2. And this is our answer. So we found our x value. If you want to, if the question asks for you to find the point, then you just plug in this x value into the original equation. But we've accomplished our goal of finding the c value that we can replace for x in the original function to find where the derivative or the horizontal tangent line is equal to 0. Now, let's get into some practice problems. If you think you know how to do this one, pause the video and try it. This one says apply the Rolle's theorem to f of x equals x squared minus 4x plus 4 on the interval 0, 4. And in order for us to use the Rolle's theorem, we need to meet 3 requirements. The first 2 are if it's continuous over the interval and if it's differentiable over the open interval. And since this is just a regular quadratic, it's going to be continuous and differentiable, obviously, so those 2 conditions are guaranteed. And the third condition is that f of a equals f of b, where in this case 0 is our a and 4 is our b, which is like the endpoints of the interval we're working on. So first, let's check for f of 0. And this is equal to 0 squared minus 4 times 0 plus 4, which is equal to 4. Now let's check f of 4, which is equal to 4 squared minus 4 times 4 plus 4, which is 16 minus 16 plus 4, which is also equal to 4. And we can see both of them equal 4, which means that our f of a is equal to f of b, which means that we can apply the Rolle's theorem, which states that in between this interval, there exists a value c such that there's a horizontal tangent line where the derivative is 0. And in order to find this, we just need to set the derivative equal to 0 to find the value. So f prime of x is equal to 2x minus 4. And we set this equal to 0, and we get x equals 4 over 2, or 2. But usually on a test or homework question, when you have a question like this, it'll ask you to like find the c value so that the Rolle's theorem guarantees something. If it says that, then you write c equals 2. That's what you usually would write on a question involving the Rolle's theorem. And that's our final answer. Now, let's do another practice problem. If you think you know how to do this one, pause the video and do it. This one says apply the Rolle's theorem to f of x equals x cubed minus 3x squared plus 2x on the interval 0, 2. And as always, we need to see if it meets the 3 requirements. The first 2, continuous and differentiable. I've already said this a lot of times. And this one's also a polynomial, and obviously it's going to satisfy both conditions. And let's check for the final condition, where f of a is equal to f of b, where 0 is our a this time and 2 is our b. Let's check for f of 0, which is 0 cubed minus 3 0 squared plus 2 times 0. And this is just equal to 0. Now time for f of 2, we get 2 cubed minus 3 2 squared plus 2 times 2. This is equal to 8 minus 3 times 4, which is 12, plus 4, which is also equal to 0, which means that we can apply the Rolle's theorem to this because f of a is equal to f of b. They're both equal to 0. And again, we have to find the derivative and set it equal to 0. So f prime of x equals 3x squared minus 6x plus 2. And now, this isn't as simple. We have a quadratic this time. So if we want to find where the c value for f of c equals 0, we need to replace x for c. So we write it as 3c squared minus 6c plus 2 and set it equal to 0. And we can use the quadratic formula to do this. So let me erase this part to do it up here. And we can write it as c equals 6 plus or minus the square root of 36 minus 4 times 3 times 2 all over 2 times 3. Now let's get to simplifying this. So we get 6 plus or minus the square root of 36 minus 4 times 3 times 2, which is 24, over 6. And let's rewrite what's inside the square root. 36 minus 24 is just 12. And now we have 6 plus or minus square root of 12 over 6, but we can factor out a 2 from the square root, and we get 6 plus or minus 2 times the square root of 3 all over 6, and factor out a 2 from everything, and we get 3 plus or minus square root of 3 over 3. And that's our final answer. Now, let's do one last practice problem. If you think you know how to do this one, then pause the video and try it. This one says apply the Rolle's theorem to f of x equals sine of x plus cosine of x on the interval 0, pi. And sine of x and cosine of x, they're just trigonometric functions which are both continuous and differentiable. So the first two conditions we need to see if it meets are automatically satisfied. And as always, we need to see if f of a is equal to f of b, or this time a is 0, so let's find f of 0. It's just sine 0 plus cosine of 0. This is equal to 0 plus 1, which is 1. Now let's find f of pi. This is sine of pi plus cosine of pi, which is equal to 0 plus -1, which is equal to -1. And look, you can notice that -1 and 1 are not equal, which means that f of a does not equal f of b, and therefore Rolle's theorem does not apply. You should write it out like this. And that means we cannot find the c value such that the slope in between this interval is equal to 0. So everything that I explained in this video and all the prompts I went through should teach you everything that you need to know about the Rolle's theorem and how to use it. If you learned something from this video, or if you enjoyed it, then please consider liking and subscribing.